Hi all, in this session we are going to learn about bit stuffing and HDLC. First let's understand what is HDLC. High level data link control or HDLC is a protocol which basically provides reliable delivery of data frames over a network or a communication channel. HDLC provides various operations such as framing, data transparency, error detection and correction, and flow control. There will be two types of stations in an HDLC protocol. There will be primary stations which simply transmit commands that contain the address of secondary stations. The secondary station then simply transmit a response message which contains its own address. So in a simple point-to-point communication, the primary station will issue a command which contains the address of the secondary station. So this system's address will be encapsulated in this command, and this command is sent to the secondary, and the secondary station will encapsulate its address in the response message and it will be transmitted to the primary station. In a multi-point connection also the same concept. The primary station will issue the command with the address of secondary stations, and the secondary stations will respond to its primary station using its response message which contain its own address. So this is the basic concept of HDLC. Next let's learn HDLC frame structure. The typical HDLC frame structure consists of the following segments. There will be a flag which is of 8 bits. There will be an address field which is of 8 bits, or even we can extend it up to 16 bits. Then there will be a control field which defines the different types of frames, and this control frame will be either 8 bits or 16 bits. And then the information frame where we are encapsulating our data to be transmitted from the sender to the receiver. And then there will be a error detection mechanism which is called as FCF, frame check sequence, which uses cyclic redundancy check method to identify whether there is any error in the sequence or not, and then the ending flag which is of 8 bits. So in a typical HDLC frame structure, the flag will be always, the starting flag and the ending flag will be always 0 1 1 1 1 1 1 0. So this is same in a typical HDLC frame structure. So whenever the data is received by the receiver, whenever it is getting a 0 followed by 6 ones and a 0, it will assume that the beginning of a frame is started, and then it will process the information. And whenever it is getting the second flag which is 0 1 1 1 1 1 1 0, then it will assume that the end of the frame is reached. So this is how the data transmission takes place. So let's understand each field in detail. The first one is the flag field. The flag field is generally responsible for initiation and termination of error checking. It is a 8-bit sequence. Usually for an HDLC frame format it will be 0 followed by 6 ones and a 0. Next is address field. If primary station creates the frame, it contains two address, that is the destination address. If secondary station creates the frame, it contains from address. We have already mentioned that the primary stations will simply transmit comments that will contain the secondary station's address, that is the to address, and the secondary station then simply transmit response message which contains its own address, that means the address of the secondary station, that is the from address. So that concept is explained here. So the primary station creates the frame which contains to address, and the secondary station creates the frame which contains from address. Control field is a field used for flow and error control. There are different types of HDLC frames. Basically 3 types of HDLC frames are there. This type of frame is determined by the control field in the HDLC frame structure. Next is the information field which contains the data to be transmitted, and the next field is FCS field which is frame check sequence, which is the HDLC error detection field. So this field is used to ensure whether an error is occurred during the transmission or not. For that purpose we are using cyclic redundancy check. So let's understand what are the different types of HDLC frames. There are typically 3 types of HDLC frames: information frame, supervisory frame, and unnumbered frame. It is also called as I frame, S frame, and U frame. This is the frame structure of I frame, S frame, and U frame. An I-frame stands for information frames. The frame is generally used for transporting user data from the network layer. So these frames actually carry actual data or information of upper layer, which is the network layer, and some controlled information regarding that. This iframe carries data along with both send sequence number and an acknowledgement. The S frame stands for supervisory frames, which basically required and is essential for error control and fraud control mechanism. It also provides control information. It contains acknowledgement number. And the last is U frame, which stands for unnumbered frames. This is usually used for link management, that is establishing the link between the sender and the receiver. These frames basically support control purposes and are not sequenced. Next, let's understand the need of bit stuffing in HDLC. The typical HDLC frame format is shown here. The 8-bit flag bit, and then the 16-bit control information or the header, then the data that is being transmitted, and then the CRC checking, which is used for detecting errors, and then the final flag bit, that is again 8-bit. So here the data being transmitted is this particular sequence of bits. So from the sender, these bits are transmitted to the receiver side. So the bit pattern used in HDLC to identify the beginning and end of a frame is 0, 1, 1, 1, 1, 1, 1, 0. So whenever the receiver encounters this pattern of bits, that is 0 followed by 6 ones and a 0, then it will identify that it is the beginning of a frame. And whenever the receiver is again getting a sequence like 0 followed by 6 ones and a 0, then the receiver will identify that the frame is end. But what if there is a data part like 0, 1, 1, 1, 1, 1, 1, 0, that is 0 followed by 6 ones and 0. If the ending sequence is appearing in the data part, then the receiver will assume that the end of the frame is received and it will reject the other bits after that. So this is a problem. So how to avoid this problem? For preventing from this problem, the sender of the frame stuff some bit on the body for disarranging the pattern of ending sequence. This technique is known as bit stuffing. So consider the data sequence or the bit sequence here: 1 1 0 1 0 1 1 1 1 1 1 0 and so on. This is a sequence without bit stuffing. As we all know that an HDLC frame format, the flag is 0 followed by 6 ones and 0. Here in this data part itself, there is 0 followed by 6 ones are there. So whenever the receiver is getting this particular part of data, the receiver assumes that the end of the frame is occurred and it will neglect the other bits. In order to avoid that, what we will do is, whenever the data contains 5 ones in continuous location, we will stuff with an extra bit called 0. So see here, whenever 5 bits are there, we are adding a new bit 0. So check here from here, 1 1 0 1 0 1 1 1 1 1. So 5 bits are there. Then after 5 bit there is 0 1. So after 5 bits we are stuffing with a new bit 0, and again we are adding the other values, that is exact 0 1 0 1 1 1 1 1. Again 5 ones are encountered, so we are stuffing it with again a 0. Then the same data is packed back to back, and again we are encountering 5 ones in continuous location, so again we are stuffing it with a new bit called 0. So this is called as bit stuffing. So the sender will stuff with zeros whenever it encounters 5 consecutive ones. So at the receiver side, whenever the receiver is getting continuously 5 ones, it will skip the next bit, because the receiver knows that the 6th bit after 5 consecutive ones will be a stuffed bit, so it will neglect that bit or skip that bit, and thus it will regenerate the original frame. So this is how bit stuffing helps in HDLC protocol. The sender will always do the bit stuffing and the receiver will undo bit stuffing. So in this diagram, if we want to transmit this data 0 1 1 1 1 1 1 1 0, so after encountering the first 5 ones, the system or the sender will add a 0 here. So it will be like 0 followed by 5 ones and a 0 again, then 1 0. So this is the concept of bit stuffing. Thank you.